Hi everybody, welcome back. We are now going to talk about some of the properties of the exponential function. So they kind of fall into two categories. These are the exponent laws. And basically the exponent laws are there to simplify or rewrite an expression. Because usually, as we'll see in the following examples, the equations or functions given will not be in a form that we can directly solve, so there's usually some sort of simplification or rewriting procedure that is required to do that. And so these exponent laws, which you should be familiar with, gives us one way to figure that out. Then once you get into a suitable form, then you want to use one of these solving properties. The first one says is that if you have the same basis but different exponents, then the exponents must be equal. And the second property says if that the exponents equal and are not equal to, and they're not equal to 0, then the bases also must match. So this gives us a way to kind of attack the problem. So let's look at an example. We have 4x to the squared equals 8 to the x. So kind of the trick is that you want to use one of these two properties, and usually the one you're going to use is a. So that means that you want to get the bases to match somehow. So notice that both 8 and 4 are powers of 2. So if we can write both of these as terms of base 2, we are fine. So note that 4 squared or 4 is 2 squared and 8 is 2 cubed. So we're going to write 2 squared for 4 and raise it to the x squared power, and this would be equal to 2 cubed for 8 raised to the x power. And then we're going to come up here and use this property on both sides of the equation. So in this case we'll get 2 raised to the 2x squared power. On the other side we'll get 2 raised to the 3x power. Now notice now that we've set up property A from the solving properties. So that means that since the bases are equal, the exponents too will also have to be equal. And now this is a quadratic we know how to solve. So we are going to have, let's get rid of the side work, that 2x squared minus 3x equals 0. We can factor out an x. We get 2x minus 3 equals 0. And then the zero product property says that x equals 0 or 2x minus 3 equals 0. And so we'll get 2x equals 3 and x equals 3 halves. So these are the two solutions for that. So notice that I had to rewrite the basis first, use my solving property to get from this step to this step, and then this created a quadratic that I knew how to solve. So let's look at a slightly different example here. This is x squared e to the x minus 5x e to the x equals 0. If you don't know what e is, that is the next section. You'll be reading about base e, and that's just a particular base. E is approximately equal to 2.7. So, but it is a rational number that is very important in mathematics, just like pi is. So you'll see this a lot with exponential functions. But one of the facts we want to use in this is that, well, in general, a to the x is equal to 0, and in particular, e to the x is always greater than 0. So notice that the first thing that looks kind of logical to do is you should be able to factor out an e to the x. And in fact, you can factor out more than this, but I just wanted to factor the e to the x first to keep things simple. So notice you get e to the x times x squared minus 5x equals 0. So that means by the zero product property that e equals 0 or x squared minus 5x equals 0. And notice that this is a violation of this property. So this is always false. So this comes up sometimes in exponential problems where you'll get an exponent equal to 0. And that is always a false statement. And reminder that if you have a transformed exponential function, that's not necessarily true. But for just one of your base exponential functions, this is always false. So really the only solutions are going to come out of this part here. So we'll have x times x minus 5 equal to 0. Which is all good. So either x is going to equal to 0 or x is going to equal to 5. And these are your two solutions. So there's some examples of solving for exponential functions. So up next, I'm going to let you read base E on your own. So we'll talk about compound interest next. See you then.